Hello, now I'm going to talk about defensive programming. And defensive programming is a technique that you follow such that your program is more robust. How? Well, usually when you write your code and you write your methods, you consider there is a contract. So you expect that who's invoking you uh, is going invoking you in the conditions of the contract. And you may follow this principle that is garbage in, garbage out, in the sense that, okay, if I'm not invoked in the conditions of the contract, I don't care, I just execute and I don't care what's going to happen. But in defensive programming, you're going to care. So you're going to check whether the situation is what is expected. And then you can do two kind of decisions when you check this. The first one is you can decide that, okay, I'm going to inform. And then if you're going to inform, you're going to say that you are doing error handling. Okay, so you inform that the error occurred. In other cases, you just crash the program, say, I cannot be invoked in these conditions. And you do this with assertions. The question is, in which cases should you use each one of the approaches? So the main idea is that to protect your program from what will never happen is you can use exceptions. But to protect it from an invalid input, for instance, it's something that you don't expect it to happen, but may happen, you do error handling. And actually what you decide, almost from an architectural point of view in your program, is called what is called barricades. So the idea of barricades is places where you basically try to filter everything that is received and say, okay, I'm gonna do, if something occurs inside the barricade, is a safe area. And so in this case, this is really a bug of my program, and probably I'm gonna just throw an exception. But I expect that outside the barricade, things can happen not according to what is in the specification. Okay. So the barricades designate certain interfaces as boundaries to safe areas. Okay. And so what are assertions? That's the techniques you use when you know that things should not happen. Basic assertions in the code is you write in as you write your code, you write assertions like this that verify the state of the code. So in some sense, what you are doing, you are specifying what should be the state of the execution of your program in that point. Okay, and you throw an exception if the condition is not true. Okay, so another advantage of assertions is that they are a specification. They can be used. You are specifying what should be the behavior of the program in that point. Okay, so for instance, you specify that this condition that the denominator should be different from 0. Okay. Then for error handling, I'm going to show you an example. For instance, in this method, well, this method, I think we have seen this method before. So this is a parser binary function that receives a cell and a string. And this string can be whatever you want. So you expect this string is a regular expression, is according to a particular regular expression, okay? But you don't know. If you don't trust who's going invoking, so if this is in the border of the barricade, you should throw an exception there that is a kind of error handling, okay? And so you throw an exception, and this exception just informs that this is not the way, so it doesn't match a particular regular expression there. But once you are inside here, you expect that all the type of binary elements, so in the first token of these, that you after you parse this, in the first token should be one of these operators. If not that's the case, you should say assert false. So for the default, we explicitly say assert false. You don't throw an exception here because you are already inside the safe area. So you agree that the problem is not because of the expression. The problem is that because you forgot to write one more case here. Okay. In terms of error handling, you can either use exceptions and notifications. A lot of people do not like to use exceptions. Why? Because exceptions is a way that basically just is like a go-to. You just say, okay, I don't care, and you throw this exception, and you don't know who's going to catch it. Okay. Some programming languages do not support exceptions anymore because of that. But and then you can use notifications, and in notifications basically you return so that your error message, so the information, your error notification goes the same flow of execution, so the same way it was executed. So it means that who's going to who has invoked is going, the invoker is going to receive this notification. Okay, but so if you use exceptions, one thing is the exception should be strongly related. So the question most of the times arise is, when should I use exceptions? Okay, and exceptions should be related with architecture. So I think that one nice way to deal with exceptions is to define it at an architectural level. So you say, in this layer I throw exceptions, and then I catch the exceptions and throw to an higher level layer. So you can relate basically exceptions with the levels of abstraction of your code. And in that way you can manage them. So for instance, if you have an employee, and if you try to read something, suppose that is an end-of-file exception, but could try to be an access to the database, it makes no sense to throw this type of exception because you are in the domain layer. So it's much better to, if you actually get that, if you get an exception from accessing to the database, you convert it into an exception that is employee data not available, which makes sense at this level of abstraction. Okay. So this idea that exceptions are an architectural decision. And then you have notifications. The idea of notifications is that you create objects and you return these objects with errors, and you just put information inside this object. Well, this is basically you have these objects that you send information. What happens with the programming languages that actually do not support or provide a better mechanism for error handling than exceptions is that in their constructs, for instance in Go, every function returns two values. One is the result value, and a second value is the error value. And this error value is one of these objects, is a notification. So, and you program, and you can just look at this notification and see what is the error that you're going to receive. Okay. And then you can see here an example. Okay, enjoy.